Today my printed circuit boards came in. I've assembled some components on them. I've 3D printed a case and made up some cables. This is the temporary display I've made up to show gear changes. Imagine this is an earth wire rubbing on the, that's the neutral point there. See, it displays a 0 and a 1 and a 2 and a 3 and a 4 and a 5, or you'd go back through the gears 4, 3, 2, 1, and neutral showing as a 0 on my little display. That's sort of how it's supposed to work on the bike. What I've done is I've made up a heavy cable there which would run from the sensor. The sensor's ready to mount on the motor. That's a nice waterproof connection there. Heavy 6-core cable running up to the dashboard, where there's then a simpler 6-pin connection to a lighter cable that runs across into the display I've built. And the display has a single wire that goes to an ignition 12-volt line. So the current runs from the 12-volt line to the display, through the LEDs and down to the neutral switch, which earths whichever of the 6 wires to display the 6 different gear ratios. So that's sort of how it works. The post has arrived. These are the printed circuit boards I've had back from China. They're very professional. 10 of those came in, cost me $38 including the freight. It was here within a week from China. Ordered on a Friday and received on the following Friday. That's a pretty good service. Came on DHL freight. They're a neat little board. This is a circuit board made up with the LEDs soldered on. I don't have all the correct value resistors. They need a different value resistor depending on how many of the 7 segments are displayed on each LED. I only had a limited selection here at home, so I paralleled some together. There's different values required because a number 1 only has 2 legs LED segments displayed. If they're 20 milliamps per segment, it needs 40 milliamps to run through a number 1 display. But a number 0 has 6 segments displayed, so 6 times 20 milliamps needs 120 milliamps run through. So there's only about 70 something ohms on the 0 and about 300 ohms on the 1. And about 110 ohms I've made up by just paralleling. I had 220 ohm resistors, so I paralleled some together. And I've got them all the same on whether it's 4 segments or 5 segments, but I dropped it back a bit further for 6 segments. So that's pretty messy. There's space in the case that I made for all that rubbish hanging on the back of the board. The little case, first of all, there's got a cut out in the end. The board fits neatly up inside. Yeah, it drops in like that, and then a simple base cover here with a cutout in the end for the connector to go on. So these were just, this case was just 3D printed off the Fusion model for the board. This is the base cover for my gear selection display case. It's laying down a 4mm thick 50% infill base. Fusion 360 board design, you can import the 3D rendering of the board back into the package and design a case that goes around it perfectly. That's the prototype case back together. I'm not real happy with the way the connector worked out on it. This is just a prototype and the case can be reprinted. The circuit board, a little bit more difficult to get more circuit boards made. to a different design, but this one sort of works, and it's really just comes down to how the case works. Yes, I'm not real happy with this lightweight connector I've used on the end. Really, that probably would be better contained inside the case and just a cable gland coming out of the box. But look, this is just a proof of concept type prototype, so I may go and tape it onto the quad bike above the dash and ride around with it and see that it physically works on the bike. I've got little doubt that it won't. It will work. This is temporary. The actual neutral switch that I made is a robust, reliable product. So long as it doesn't melt, it's just PLA. I don't know whether the engine casing is going to get hot enough to affect the plastic that I've printed that out of. If it does, I can print a new one out of something a bit more resistant. Where this project could lead is a more sophisticated dash. This has got no logic in it. It's just basically 6 LEDs being lit up and just resistors dropping the adjusting the current for each LED. So there's no logic involved in the circuit. This neutral switch sensor could be used on a much more sophisticated dash that displays the gear position, and potentially on the old quad bike provide a rev counter and maybe a temperature gauge and possibly an oil pressure. Things that you'd normally see on a more sophisticated dashboard run by a Arduino or something like that. This was just a proof of concept dash, which could have been mocked up out of more basic materials, but when you've got a 3D printer and you can get a circuit board made cheap, worth spending a little bit of time on it and making it more of a learning exercise. So that's what I've done. Now I need to go and mount it on the bike and burn around, see whether it works. Get out to your shed and have some fun.